This video is about the sum of an infinite geometrical sequence. This is the formula for the sum of an infinite geometric sequence. S sub infinity equals U sub 1 over 1 minus R, the absolute value of R less than 1. Absolute value of R less than 1, which means this R common ratio greater than -1, less than 1. If a sequence converges, it means that the limit of the sequence exists as n approaches infinity. If the limit of the sequence as n approaches infinity doesn't exist, the sequence diverges. A sequence always either converges or diverges. There is no other option. When absolute value of a common ratio less than 1, the limit as n approaches infinity of the geometric sequence U sub n equals 0. So the geometric sequence converges when the common ratio greater than -1 and less than 1. Let's look at the example. We have U sub n equals 5 times 1 over 2 to the nth power. Then we have A sub n equals 5 times 2 to the nth power. For U sub n, the common ratio is 1 over 2, which means absolute value of R less than 1. Then the limit as n approaches infinity of 5 times 1 over 2 to the nth power. 1 over 2 to the nth power. We can write down 1 over 2 to the nth power. As n approaches infinity, we do know 1 over 2 to the nth power approaches 0. Therefore, limit as n approaches infinity of 5 times 1/2 to the nth power. This is 0 as n approaches infinity. 5 times 0 is 0. For A sub n equals 5 times 2 to the nth power. As n approaches infinity, we do know 2 to the nth power approaches infinity. In other words, this limit as n approaches infinity of A sub n doesn't exist. So A sub n, this geometric sequence diverges. Since the limit as n approaches infinity of U sub n equals 0, we see U sub n converges. Find the sum of the following infinite geometric series. For A, the sum of 3 times -2 to the k minus 1th power as k goes from 1 to infinity. We know the base is a common ratio, so R equals -0.2. We know the absolute value of -0.2 less than 1. So we can use the formula S sub infinity equals U sub 1 over 1 minus R. We know k equals 1. Then 3 times -0.2. 1 minus 1, that is 0 power, equals 3. This will be U sub 1. the r is negative 0.2. Sum of the sum of the infinite geometrical series. The sum of 3 times negative 0.2 to the k minus 1's power as k goes from 1 to infinity equals 3 over 1 minus negative 0.2. That equals 3 over 1.2. Simplify. Multiply by 10 first, 30 over 12, then reduce. 5 over 2, that equals 2.5. For D, sum of 2 times 1 over 3 to the k plus 1's power. K goes from 3 to infinity. First of all, just check the common ratio. That equals 1 over 3. Since the absolute value of 1 over 3 less than 1, we can use this formula. K equals 3. So 2 times 1 over 3 to the 3 plus 1 is a 4th power. That equals 2 over 81. This will be usable 1. Then we plug in here. Usable 1 is 2 over 81. 1 minus 1 over 3. Top and the bottom, we multiply by 81. You will get the 2 over 81 minus 27. That equals 2 over 54 reduce 1 over 27.